This is random variable. Random variable is a set of possible values from a random experiment. If we say experiment, one of the example is tossing a coin. We have this one as our example of doing an experiment. In addition to that, when we throw a dice, we have this one is also an example of an experiments, and then set of possible values. So these are the values for our random experiment. So when we say random variable, we have here our example. Let's say x as our random variable. Let's say x. We have, when we toss a coin, we have let's say 1 and 0. For 1, let's say this indicates our head, and then 0 here is the tail. So we have here, when we toss a coin, so we can have here as 1 0. Okay, thus when we have our random variable, when we write our random variable, we have here x is equal to the sets of value, let's say 0 1. Okay, or another way of writing a random variable, another example of writing a random variable, we have here 1 2 3 4 5 6. This is a case when we throw a die. This is a die, and then this die has a number 1 2 3 4 5 6. So these are the values of our die, no? And then these are our experiment when we throw a die. Okay, so this is now what we call as the random variable. Now in a die, we call this 1 2 3 4 5 6 as our sample space. So we have our term sample space. Okay, these are now our sample space. 1 2 3 4 5 6. We have this one as our die. Now in talking also about random variable, we have what we call as the probability. The word probability, these are possible outcomes. Possible outcomes. Okay, so this is how we describe the probability. And take note also that the sum of probability, so note, let's say sum of probability is equivalent to 1. So that is the sum of probability, which is equivalent to 1, or in percent, that is 100%. Now we have again our example. Okay, we have throwing a die. When we throw a die, let's say throwing a die. Okay, so we have here a die. When we throw a die, we're going to find the probability. Now, by the way, when we write our probability, we have here the probability when x is equal to 1. That means, okay, when we throw a die here, this die will appear a number which is 1. Okay, now since this is a die, for example this one, there are 6 numbers, 1 2 3 4 5 6, wherein we call it as our sample space. So that when we write the probability when x is equal to 1, so if you count this one, how many number 1 here. So we only have 1 out of 6 numbers. So that when we write our probability when x is equal to 1, that is equivalent to 1 over 6. Okay. Now, how about the probability when x is equal to 2? The probability when x is equal to 2, so if you have noticed, there's only one number 2 here in our sample space, so we have 1 over 6. Take note, over 6. 6 is the total sample space here. Okay, 6. Now, how about the probability when x is equivalent to 3? When x is equivalent to 3, then we only have one number 3 here in our sample space, so 1 over 6. And then, how about the probability when x is equivalent to 4? The probability of x when x equivalent to 4, that is 1 over 6. We only have 1 4, 1 5, and then 1 number 6. So when we write the probability when x is equal to 5, that is equivalent to 1 over 6. The probability when x is equal to 6, that is equivalent to 1 over 6. Because there's only one number 1, one number 2, one number 3, one number 4, one number 5, and one number 6. That is why we have here 1 over 6. So these are the probabilities of throwing a die. We have here another example. In throwing of 2 dice, find the probability on the sum of their scores. So we have our 2 dice. So we throw this one. So let's say we have this one, a die contains a number, let's say 1, 1, 2, 3, 4, 5, 6. And then this is for first die. And then the second die, we have here 1, 2, 3, 4, 5, and then 6. So we call this one as the second die because these are the 2 dice. Okay? So when we throw a die, let's say first die will appear 1, and then the other die will appear 1, then their sum is equal to 2. Then also, let's say when this die is being thrown and then the other one is thrown, let's say this one is 1 and then this one is 2, then the result will be 3. The sum is 3. And then let's say the first die is 3 and then the second die is 1, their sum is equivalent to 4. And then 4 and 1, let's say 5. And then 5 and 1, that is 6. 6 and 1, that is 7. So these are the results, sample results when we add the scores of 2 dice. Also, there might be a possibility that the first die appears to be 1 and then the second die is 2. So their sum is 3. And then 2 plus 2, let's say 4, 5, 6, 7, 8. And then 3 plus 1, that is 4. 3 plus 2, that is 5, 6, 7, 8, 9. So there's a format for this one. And then 4 plus 1, that is 5, 6, 7, 8, 9, 10. 5, 6, 7, 8, 9, 10, 11. And then we have here 6 plus 1, that is 7, 8, 9, 10, 11, and then 12. So these are the possible outcomes when we throw a dice, 2 dice. Okay. So the total outcome, if you have noticed, we have here 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6. So all in all, there are 36. We have here 36. 6 times 6, that is 36. Okay. So these are our total outcomes. So we have here total outcomes, which is equivalent to 6 times 6, that is 36. Okay. Our sample space here, we will write sample space. Okay. Our sample space for this case, we have, let's say, x is equivalent to. So we have our sample space, which is this one. So we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So these are the sample space. These are the possible outcome. Okay? Sample space. Now, find the probability on the sum of their scores. So, let's say these are the scores, the sum of the scores. So, the probability of having 2 when x equals 2. So, I will write here the probability when x is equal to 2. So, if you have noticed, there's only one number 2 here. So, that is 1 over 36. Our possible outcome, 1 over 36. Now, the probability when x is equivalent to 3, for this case, that is equivalent to, if you count number 3's here, our possible outcome, we have 2. 1 and then 2. So, that is 2 over 36. Or when we reduce this one to lowest term, that is 1 over 18. Always reduce to lowest term. Now, the probability when x is equivalent to 4. Okay, how many 4's we have? 1, 2, 3. So, we have 3 over 36, or that is equivalent to, they are divisible by 3, so 1 over 12. And then the probability when x is equivalent to 5, okay, that is equivalent to 5, 1, 2, 3, 4, so 4 over 36, which is equivalent to, these are divisible by 4, so 1 over 9. The probability when x is equal to 6, so 2 4's 5, so that is equivalent to, how many 6 we have? 1, 2, 3, 4, 5. So that is 5 over 36. How about the probability when x is equal to 7? So when x is equal to 7, how many 7's we have? 1, 2, 3, 4, 5, 6. So that is 6 over 36, or that is equivalent to, they are divisible by 6, so that is 1 over 6. Okay, so this time the probability when x is equal to 8, okay, when x is equal to 8, how many 8 we have? 1, 2, 3, 4, 5. So that is 5 over 36. The probability when x is equal to 9, so 9, 1, 2, 3, 4, that is 4 over 36, which is divisible by 4, 1 over 9. 1 over 9. Okay, and then the probability when x is equal to 10, we have, how many 10's? We have here 3 over 36. 3 over 36, which is then equivalent to 3 over 36, that is 1 over 12. And then the probability when x is equal to 11, okay, so 11, we have here 2 over 36, or 1 over 18. And then the probability when x is equal to 12, that is equivalent to 1 over 36. So these are the probability on the sum of their scores. These are the sum of their scores. Another example, we have here a question: what is the probability that the sum of the scores are 5, 6, 7, or 8? So we're going to these questions, is based on the previous example. So we will go back with our previous example. We have this one. Okay. Now, what is the probability that the sum of the scores is 5, 6, 7, or 8? So, we have to find the probability of the sum, which is 5, 6, 7, and then we have here 8. Okay. Sorry. So, we will write our probability as, let's say, P, uh, 5, 6, 7, or 8. That means we have here when x is greater than or less than 8. Okay. That the sum of their scores is 5, 6, 7, 8. That means the probability when x is greater than or equal to 5 and less than or equal to 8. So that when we write our solution, that is the probability when x is equal to 5 plus the probability when x is equivalent to 6 plus the probability when x is equal to 7 and the probability when x is equal to 8. So that when we solve this one, we have to look at our sum of probability when x equals 5. So we have here 1 over or 4 over 36. Okay, so 4 over 36, x equals 6, that is 5 over 36. So 5 over 36 plus 7, that is 6 over 36, plus the probability when x is equal to 8, 5 over 36. So 5 over 36. Okay, 5 over 36. So when we sum up this one, 5 plus 5, 10, 20 over 36. So we arrive at 20 over 36, and then this is factorable by 4. So divided by 4, that is 5. Divided by 4, that is 9. Therefore, our answer here, what is the probability that the sum of the score is 5, 6, 7, or 8? Our final answer is 5 over 9. Okay, so that is our final answer. Now, additional question. Let's say another example. This is in continuation with our problem here. If, if the probability, let's say P, of x when x is equal to 1 over 12, what is the value of x? So when x is equal to 1 over t, or mean if the probability when x is equal to 1 over 3, what is the value of x? So 1 over 12, the probability when x is equal to 1 over 12. So we will look at our value here. If you have noticed, 1 over 12, we have this one, x is equal to 10, and then for this one, 1 over 12, x is equal to 4. Okay, thus the value of x is 4 and x is equal to 10, wherein this value of x has a probability of 1 over 12. So 4 and 10. That will be our final answer for this particular problem. Now, random variable can either be discrete or continuous data. Okay, so we will write here random variable random variable can either be discrete data, sorry for that. Allow me first to erase. We have here our random variable can either be discrete or continuous. Discrete data can only take certain values such as, let's say, okay, such as 1, 2, 3, 4. And then also, for continuous data, can take any value within a range. So we have our example for discrete data. So let's say example of discrete data is the number of students in a class. Number of students in a class. Okay. If you have noticed the number of students in a class, example of the number of students in a class, let's say 35. Okay. So 35, 42, 20. In other words, these are all whole numbers. Another example is the results of rolling a dice. So rolling a dice or a die. So the results of rolling a die, we have, what are the results of rolling a die? We have 1, 2, 3, 4, 5, 6. So these are some of the example for discrete data. Now how about continuous data? Now our example of continuous data, let's say we have here the person's height. Okay, person's height. If we say person's height, okay, let's say 5 feet 12 inches. Okay, I mean 5 feet 4 inches, or let's say 5.35 feet. Okay, and another example is, let's say, time in a race. Time in a race. So let's say 3 minutes, 4 seconds, or let's say 3.34 minutes. In other words, for discrete data, these are whole number. And for continuous data that can take any value within a range, uh, it can be a whole number, but there are decimals, let's say 5.35. So it might be 5 or 5.35. But for discrete data, these are whole number. 1, 2, 3, 4, 5, 6, 45, 46, 47. So that is how we identify the discrete data. So for this case, the number of students in a class, you will not say 2.5, but you will say there are three number of students in a class. There are 11 number of students in a class. So for the sum of rolling a die, for example, the sum of rolling a die is, let's say, 6. You cannot say 3.5 or 4.6. But your answer will definitely, let's say, 7, 8. Okay. And for continuous, of course, when for example, this one, continuous data, person's height, 5 feet 4 inches or 5.35 feet. Okay, so these are the difference between discrete data and continuous data. These are part of a random variable. In our discussion about random variable, which can be either discrete or continuous, we have here our another example for a discrete probability distribution. So say for example, we have considered the discrete probability distribution below. Find the probability that x is equivalent to 4. So we have this one as our discrete probability distribution. Okay, this is a table with the value of x and the probability of x. So when x equals 1 and then 3, then 4, let's say 6 and then 7, and then the probability when x equals 1 is 0.02. The probability when x is equal to 3, let's say 0.18. And then we do not have a value when x is equal to 4. And then let's say the probability of x when x equals 6, we have 0.29. And then the probability when x is equal to 7 is, let's say, 0.34. Now, going back to the question, find the probability that x is equal to 4. We have this one. Okay, so again, this is our discrete probability distribution table. Okay, and then we're going to find the value of its probability when x is equal to 4. So when we solve this one, take note that the probabilities or the sum of probability is equal to 1. So if you have here this probability of x, so we have to add all this value. Okay, so we have the sum of the probability is equal to 1, so we will write here 1, which is equivalent to 0.02 plus 0.18 plus the probability when x equals 4, which is unknown. Okay, the unknown value, and then plus 0.29, and then plus 0.34. So that when we combine all this value, we have, okay, I will change this one, 1 minus, I will transpose this one on the other side, 2.02 minus 0.18 minus 0.29 minus 0.34, which is equivalent to the probability when x is equal to 4. So that when we solve this one, okay, so this is 2, 18, that is 20, 49, 50, 60, 70, 83. 100 minus 83, that is 0.17. 0.17. Okay? Or you can make use of your calculator to solve this one. The result is 0.17. This is now our final answer.